CRISP stands for Cross-Industry Standard Process. It's a structured approach for data mining broken down in 6 steps. The first is business understanding. Here we make sure to understand the business goals and priorities to tailor the data mining project in accordance with them. The second step, data understanding. It's where we gather data, ascertain its qualities, check for errors, missing values, and inconsistencies. From there we begin the data exploration and calculate descriptive statistics for our first insights. The third step is data preparation. Here we clean the data and fix any issues we encountered in the previous step and document what was the method for resolving them. And if necessary for the project, we will derive new columns or variables based on the key questions we're aiming to answer. The first step is modeling. Here we choose a model for the dataset and create a test plan for it. This is a prototype model that will be tested and hopefully validated. We will document the testing methods and assumptions that we made. The fifth step is evaluation. It's the point where a compliance committee assesses whether the model meets the business's goals and objectives. We'll create visualizations of the model's result and present them to the committee for approval. They will determine if the model should be implemented, discarded, or revised. The sixth step is deployment. It's where the model is finally implemented and we make sure to document its performance, investigate any radical change in output volume or quality, and generate periodic reports detailing model development, purpose, quantitative threshold changes, and performance. We need to turn the non-stationary time series data into stationary by removing trends and seasonality. Forecasting models need to see consistency or predictability within the data to make good predictions. Non-stationary time series data is by nature unpredictable, making it cumbersome for forecasting models. By making the data stationary, it becomes useful to actually make forecasts. Data ethics has 4 main principles: privacy, transparency, accountability, and equality. In privacy, individuals should be in control of their personal data. Transparency means individuals should have a clear overview of the data that organizations collect and share. This means that organizations need to be transparent about how they handle and process data, both internally and externally. Accountability entails organizations are responsible for the data that they collect and share. They must safeguard an individual's private information and be held accountable if this is not the case. And the last principle is equality. Organizations must be careful not to disadvantage or discriminate against individuals or groups when handling and processing data. And when it comes to what companies can do to uphold these principles, they should follow policies of high standard like the GDPR and have a formal data security program which will ensure they won't breach any data privacy laws. I would document various observations that caused this concern in the first place and show them to my manager, explaining what I saw and asking if they see the same concern that I see. Measurement bias occurs when there's a problem with the machines or humans doing the measuring. To avoid this, machines should be routinely checked on, and people that are involving themselves within a project should be examined to determine their level of competency for the task at hand. Regression models measure the relationship between a set of quantitative variables, while classification models predict what category an entity will be into based on a set of features. If I want to know what's the relationship between age and income, I'll use a regression model, because as we can assume, as age increases, so does income, and the lower the age, the lower the income. However, if I want to know a person's income group or income level based on their sex, age, ethnicity, marital status, and number of children, then I'll be using a classification models because I'm using a number of features to put the entity in a bucket.